Today's lesson is about functions, the four representations: words, graphs, tables, and equations. Our learning target says, I can represent and compare functions numerically, graphically, verbally, and algebraically. All right, so here's an example of what I'm talking about for this learning target. We have multiple representations. Functions can be represented as words. In this case, it says an assembly line produces 30 boxes per hour. We can change that into an equation. We can create a table of values from which we can graph your data. So whenever I am doing any writing for these examples, make sure that you're copying these things down in your interactive math notebook. All right, so I've got the words for you. So for both examples today, I'm going to give you the words. From that, let's think about our variables. So we have two things we are comparing. We have boxes and we have hours. And so we want to know which is independent and which is dependent. So the number of boxes depend on how many hours this assembly line is going. So our dependent variable is our y, dependent, and it represents, in this case, boxes. Our x coordinate is our independent variable, and in this situation, it represents hours. And according to our words, it says that the number of boxes produced is equal to 30 boxes every hour. So there's our equation. All right, a table. It tells me to make a table for 5, 10, 15, and 20 hours of production. Remember, our independent variable, our x, goes in the first column. Our y, our dependent variable, that belongs in the second column. So this is boxes. And it tells me I want 5 hours, 10 hours, 15 hours, and 20 hours. So according to my equation, I'm going to take 30 boxes times however many hours the assembly line is producing, and in this case I'll have 150 boxes. Or in the second case, I take 30 boxes times 10 hours is 300 boxes. In the next case, I would take 15, no I wouldn't. I'm going to take 30 boxes times 15 hours and get 450 boxes. And in the last example, 30 boxes times 20 hours would give me 600 boxes. So I went from words to an equation to a table, and now we're ready to graph. Now remember, for graphs, it's very, very important that you have a title. So I'm going to call this one assembly line. Our dependent variable is our side label, boxes. Our independent variable is our bottom, so that's hours. So those labels are really important for me, and when I go to grade, I'll be looking for them. All right, so our hours. We are going to start at 0 right here, and then we're going to go 5, 10, 15, 20. And then up the side, I think I'll start 150, 300. I'm going to count by 150s just because that's what my data looks like. 450 and 600. All right, so in 5 hours, we have 150 boxes. In 10 hours, we have 300 boxes. 15 hours is 450, and 20 hours is 600. and I would have a nice graph that looks like this. Of course, I would use my straight edge. All right, so I went from words to an equation to a table to a graph. All right, your turn on this one. I want you to take the words that I gave you, create the equation, make sure you define your variables, which one's independent, which one's dependent, and what do they stand for in this situation. Make your table of values and end with a graph. When you are ready, you're going to come back to me for checking. All right, so we have two things we are comparing here. We have number of books and cost. Well, I think the cost is going to depend on how many books you buy. So over here, my dependent variable is always my y, dependent. And in this case, it's the cost. And my independent is going to always be my x. And in this case, it's the number of books you buy. So my equation is a little different this time. So the cost equals every book I buy times 18 times every book I buy, plus I have to pay $4 shipping and handling. It's a little bit of a different equation. $18 times every book I buy, plus $4 shipping and handling. All right, I'm ready to come down here to my table of values. Remember, my independent, or my x value, belongs here, number of books. And my dependent, or my y value, belongs here, that's cost. And it says I want to buy 1, 2, 3, and 4 books. If I buy one book, it'd be 18 times 1, $18, plus $4 shipping and handling will cost me $22. If I buy 2 books, that's 18 times 2 plus 4, which I believe is $40. If I buy 3, I believe that's $58. And if I buy 4 books, I believe that might be $76. All right, time to graph. So I am buying books. I'm going to call that, buying books is going to be my title. My independent label, my number of books, goes on the bottom. My dependent label goes on the side. So I'm going to draw in my axes. And I'm going to buy 0 books there. 1, 2, 3, 4 books. And then my cost, I think I'm just going to go by tens, which is going to be really hard on the iPad. 10, 20, 30, that's a 30, 40, 50, 60, 70, 80, 90. All right. So one book, $22, is about right there, down a little bit, I guess. 2 books is $40, so that's about right there, down a bit. 3 books is $58, so that's about right there. And 4 books is $76, which is about right there. All right. All right, so if we looked at this graph compared to our last graph, something interesting happened. In the last graph, if the assembly line worked 0 hours, you would get 0 boxes. So that first graph we did today, that was proportional. Of course, it was linear because it made a straight line, but it was also proportional because it went through the origin. But on this one, according to this equation right here, if I were to buy 0 books, I would still pay $4. Now, in reality, we know that's not true, but according to our mathematics, if we took 18 times 0, we'd get 0 plus 4. So although this is a linear function, it is not proportional.